Hello, we're going to continue talking about the process of translation. This video we're going to focus a little bit more on the ribosome. Now we'll go into a little more detail in that cellular structure. Remember, the ribosome is going to be where translation is going to happen in our cell, and that will be true for both prokaryotic and eukaryotic cells, okay? Both are going to have ribosomes. The eukaryotic ribosome, however, is different from the prokaryotic ribosome. The eukaryotic ribosome has two subunits. It's got a large subunit and a small subunit, okay? The large subunit, oops, that's the small, sorry, getting ahead of myself. The large subunit is the 60S. The small subunit is the 40S, okay? Which makes the eukaryotic ribosome overall 80S, okay? And you're going to be sitting there going, oh, wait a minute, you can't do math, Dr. Riley. Well, with ribosomes, the way this number was identified was not based on length, all right? The S actually translates to the Svedberg unit, okay, which measures surface area. So the individual large subunit around the surface area, it's going to come in at 60. The small is going to come in at 40. When they're together, you have less surface area because you have some overlap between the 40 and the 60S. So that's why it's a little bit smaller, okay? The eukaryotic ribosome is 80S. And let me do this in a different color so you have it. Our prokaryotic ribosome also has two subunits. It has a large and a small. Now, our large subunit is 50S, our small is 30S, okay? And that gives us a 70S overall for our prokaryotic ribosome. I'm not so concerned that you know the absolute numbers here. Really, the point I want to make on this, the difference in ribosomes is what allows certain antibiotics to work. Because the ribosome is different for prokaryotic cells, you can inhibit translation in the prokaryotic cell without interfering with the eukaryotic cell, because that would be important. You don't want to inhibit your own protein synthesis, okay? So we've got our ribosome, which comes in two subunits. I'm perfectly fine that you know you've got a large and a small, because that's how I'm going to draw these up here, all right? And we're going to focus on eukaryotic translation right now, because you'll get prokaryotic translation when you take microbiology, okay? The big one up here, the big Pac-Man one, well, it's not really Pac-Man, it's more the ghost from Pac-Man, is our large subunit. This is our small subunit, okay? Within that large subunit, we're going to have some certain regions, okay? And those regions are referred to as, I'm going to write it above them, the A site, the P site, and in some books you'll see an exit site. Some of them you'll just see, excuse me, the A and the P. But I put the exit site in there just so you can see it for now. And hopefully I'll draw this up there so that you can see what happens. All right. But when our large and small subunit are going to come together. And then what we're going to have the squiggly line here. This is going to be our messenger RNA. And on our messenger RNA, we're going to have our codons, right? So the AUG is going to be our codon. That's going to feed in between the large and the small subunit. And that ribosome then is going to read that, and it's going to bring in our next player here. This is going to be our tRNA. Oops, I left out a letter. Our tRNA, okay? Our transfer RNA is going to bring in our amino acid. In this case, remember, AUG corresponds to methionine. That's going to start our process. And what our tRNA is going to have is it is going to have a sequence down in this loop here, because the tRNA actually has the ability to kind of fold a little bit. That's what's going to give it its three-dimensional shape. It's called tRNA because that folded three-dimensional shape looks a little bit like a T, okay? At the very lower loop of our tRNA, we are going to have a region known as an anticodon. And our anticodon is going to be complementary to our codon. So if we have A would be U would be A, G would be C. So we've got an anticodon then, UAC, okay? What that's going to do is that's going to come in and that's going to match up. And we got our methionine here with the sequence on our messenger RNA, and that's going to start our protein chain, okay? Then what's going to happen, and this is where the animations are going to be better than me drawing on the board, okay? You're going to have that tRNA translocate or move from the A site to the P site. The RNA is going to feed in, and we're going to have our next codon that will occupy the A site, okay? Our next tRNA is going to come in, all right, and add to that protein chain, okay? So what this is going to require me to do is erase a little bit, okay? Don't let that mess you up. This is going to get a little bit messy. What color did I use for that? I used green. We've got our methionine here. We've got our messenger RNA. We've got our next codon, all right? That would bring in our next tRNA. And in this case, this would bring in a proline. All right. And what's going to happen, we've got, again, our anticodon that'll match up. If we've got CCC, our anticodon here would be GGG. What's going to happen, we're going to attach that proline to the methionine. We're going to translocate again. Now our empty tRNA, because we've removed the methionine from here, is going to move into our exit. It's going to leave the ribosome. And our protein chain will now have a methionine and our proline sitting there in the P site, okay? Things will chug back down will go to the next codon, and it'll move through the ribosome, okay? This is why I say the animations are actually a bit better for you to visualize and see how this happens. I've got a video embedded in the PowerPoint that's going to show this better. But I wanted to talk about the different components, okay? And you can see now where our 3 types of RNA are coming together during translation. We've got our messenger RNA that carries the information for the protein. We've got our tRNA that brings in the amino acid. And our ribosomes, remember, are made up of our ribosomal RNA, okay? The process of translation is going to happen out in the cytoplasm, okay? So that kind of is just a brief overview of translation. Watch the videos embedded in the PowerPoint, watch the links, because it's really much easier to see how this process is happening in the animations than it is for me to draw it. But this gives you some of the basics so that the videos won't seem so foreign, hopefully. If you have any questions, please let me know.